Hi everybody and welcome back. Today we're going to talk about quadratics. Quadratics. Okay, so quadratics is not very common in the test, but you will see this for sure. It's pretty much exponents and roots stepbrother. So here's a quadratic equation, which is the best way to present this topic. Let's do this: plus 5x plus 6. Okay, so this is a quadratic equation, and as you can see, it's got some characteristics, and these are: we have one element which is to the power of 2. In this case, we got 1x squared. Next, we got one element which is simply x. We got 5 of these, and we got one element without any x's whatsoever. That's called the free term. Okay, so what do we need to know? What I'm going to do is show you three equations which look different but are actually the same, or three things actually. Here's number one. This is x plus, let's give this 5, and x minus 2 is 0. And I'm going to also show you x squared plus 3x minus 10. Okay, we'll just talk about these two for now. Now, the first claim I'm going to make is that these two are the same. So first of all, I'll prove that they are the same. Then we'll talk about which one is better and names, how to go back and forth, which is our real job. So how do I prove that these are the same? Simply, I'll open the parentheses. I'll FOIL this one. Okay? So FOIL, if you can't remember, means if you want to open these parentheses, you do first times first, which is the f, outer times outer, inner times inner, and last times last. So let's do that. First times first, that's x times x, that's x squared. Outer times outer, x times minus 2, that's minus 2x. Inner times inner, that's 5 times x, that's plus 5x. And last times last, that's 5 times negative 2, that's negative 10. And then I'll do the math, and I get that x squared plus 3x minus 10 is 0. Okay, so first of all, I have just shown you that this equation, which means that this equation and this one are the same thing. So the first question is, which one do we prefer? Do we prefer the right one or the left one? Well, obviously, you can see in the left one, the answers are negative 5 and positive 2, because the question is, what values of x set the equation to 0? Good. So our job is to get from here to here. I'll tell you how to do that right after we'll talk about names that we have to know by heart. So let's write this one again. We had x plus 5 and x minus 2 as 0. Good. Now, I'll change colors. Each one of these is called a factor or a divisor of the equation. The solutions, however, are not that. The solutions are x is negative 5 or x is positive 2. Because these are the numbers that set the factors to 0, and so they set the entire equation to 0. The red ones have a bazillion and one names, and they are called the following. They are called the solutions of the equation. Solutions, which makes sense because they solve the equation. They're also called the zeros of the equation. Well, because it set it to 0. They're also called the roots of the equation because they are the roots of, they are solutions of equation of the second power, and they're also called the zero intercepts, or the x-intercepts. And I'll actually talk about that now. Why are they called the zero intercept? Because the graphic representation of the quadratic equation is a parabola. Okay? And these ones are the solutions and x-intercepts of the parabola, which means this point in here is going to be negative 5, and this point in here is going to be positive 2. And one last thing we have to know about the parabola, and that is that the vertex of the parabola, that is the lowest or highest point, is always exactly in the middle between the two solutions. So the midpoint between positive 2 and negative 5, that's negative 1.5, I think. And that is something we have to know. Okay, so that's about names and the parabola. Now we'll go back and see how we get back and forth between this and this. Okay, so to get from here to here, which is what we want to do, we have to play a game. I'll change colors again. We're playing a game in which we're looking for two numbers that have a product of my free term, that is 10, and a sum, which is the coefficient of the x, in this case 3. So we need to do this, open two parentheses, write x and x, and now play our game. We're looking for two numbers that have a product of 10, and that's easy. It's always easy numbers. It's either 1 and 10 or 2 and 5, but 1 and 10 will never get me to a 3. 2 and 5 might. So I know the numbers are 5 and 2. I still don't know the signs. Okay, so I need a negative 10, which means one of them has to be positive and one of them has to be negative. So, for example, could I say that this is the solution? Well, I cannot, because in this case, the product is indeed negative 10, but the sum is negative 3x, so that's not the right one. And that's exactly what I have to do, play with these numbers, which means what I have to have is a plus in here and a minus in here, because now the product is negative 10, but the sum, however, is positive 3, which is what we look for. Good. Remember, however, these are not the solutions. These are the factors. The solution, as usual, are x equals negative 5 and x equals positive 2. So basically, that's what you have to do. It's not very, very, very common, but you will see this in the test. What is a lot more common is the recycled quadratics, which I'll present right now. Recycled quadratics. Okay. So what's recycled about them? Nothing. They just keep asking about them. So these are three formulas you saw before in your life. You have to know them by heart and apply. They're kind of easy when it's with variables, and they're kind of not easy, not intuitive when it's with numbers, and you'll see that in lesson. So here's the first one. If I got x plus y squared, I have to know that this is equal to x squared plus y squared plus 2xy. If I got x minus y squared, I must know that this is x squared plus y squared minus 2xy. And the last one, if I've got x plus y times x minus y, I know that I have to get x squared minus y squared. And that's pretty much it. Now, this is something you will see for sure in the test. Usually with variables, it's quite easy to spot this. With numbers, it's a bit harder. And all you have to do is spot the right formula and change sides. That is, if you get this one, if you spot this formula first, change it to this one, and then think. And if you get this one, first change it to this representation of the same thing, and then think, and likewise here. All I have to do is change sides. That's it. So that's the topic of quadratic. As I said, it's not a big topic, but you will see this in the test, and it's going to save you a lot of time if you know these formulas by heart. That's it. Goodbye.